in actual practice, collision between any two real objects are not perfectly elastic, neither they are perfectly inelastic. So these type of collisions are called either imperfect collisions or semi-elastic collisions, right? So since we know that collision between any two real object is neither perfectly elastic or perfectly inelastic, so there must be some quantity to measure the elasticity of the collision or the extent of elasticity of the collision, right? So this is that quantity which measures the elasticity of a collision. This is called coefficient of restitution or coefficient of resilience, and it is defined as the ratio of, it is denoted by E, it is defined as ratio of relative velocity of separation after the collision to the velocity, that is relative velocity of separation after the collision to the relative velocity of approach before the collision. So I'll write it complete. We have to write relative velocity of separation before, this is before the collision, upon relative velocity of approach, which is, the separation is before the collision, right? No, I was wrong. This is after the collision. And this is relative velocity of approach is before the collision, right? So, okay, I'll give you an example, which example is the same case scenario which we are going to take for deducing the expressions for elastic collisions. So first of all, consider a body of mass m1 moving with initial velocity u1, and there is another body in the same direction of mass m2 moving with initial velocity u2. So we have supposed that initial velocity u1 is greater than u2. So that makes the relative velocity of approach u1 is greater than u2, so the approach relative velocity would be u1 minus u2. So this term here, relative velocity of approach is u1 minus u2. But this is the initial case, this is before collision case. At the time of collision, they are like this, they are imparting their energy and momentum into each other. And after the collision, now the third case is, after the collision, they are moving like this. Body m1 is moving with velocity v1 and body m2 is moving with velocity v2. The only thing is, according to the laws, if we suppose that this collision is perfectly elastic collision, the whole energy and momentum of body 1 is going to get transferred into body 2. So what will happen? The velocity v2 will automatically be greater than v1 because initially u1 was greater than u2. So here v2 is greater than v1. So what is the relative velocity of separation? This is v2 minus v1, right? So this is the value of E, the main formula for E, and we also have a method to determine the value of E. Let's see the method. Suppose we have two masses, some same masses m1 and m2, and we have hung them up using strings, okay, like the case of simple pendulum, just like that. Okay, let's make the diagram first. The formula we just wrote was v2 minus v1 upon u1 minus u2. The approach was u1 minus u2 because u1 was greater than u2. The separation was v2 minus v1 because v2 was greater than v1. Now, initial case scenario is this. I have got this body of mass m, and I have got another body of mass, okay, let's take mass m2. I was about to take mass small m and capital N, but m1 and m2 will do. This is the initial case scenario. Now we have to find the value of E, okay. What we just did, we pulled it to this height, or like this, we pulled it up to this height. So this m1 body is right now somewhere here, okay. So from the ground, just to avoid confusion in this whole thing, I am going to decrease the size of the body so that you will understand it well. So let's make the diagram again. This is our one body, and this is another body. Okay. Now this is mass m1, this is mass m2, and they are at same height or same level, right? So from this level, consider that this body m1 is pulled up to this limit, so it is somewhere here, right? Consider it height h. Now it is freed from this point, or it is allowed to fall freely. What will happen? This ball will go, or this body is going to strike mass m2, due to which two things will happen. m2 will gain energy and m2 will go in this direction. Also, second thing is the m1 is going to bounce back after hitting m2, it will go back in this direction. So what is happening right now? Once we allowed this body m1 to fall freely and hit the body m2, after collision, this is what happened. This has rose by this much height, m2 has reached here, and this m1, it bounced back after hitting m2 and it came to this point. So consider these heights to be h1 and h2, right? Simple. So we also know a formula between potential energy and kinetic energy, which is potential energy is mgh and kinetic energy is what? Half mv square. But according to law of conservation of energy, we have already explained this fact that whatever energy is possessed by this body at this height will all get converted into the kinetic energy at the lowermost point, right? So potential energy is getting converted into kinetic energy, but overall energy remains same. So this, if this is the height, so mgh will be equal to the kinetic energy at this point, which is half mv square, right? So mgh, m cancels out, so we get v square is equal to 2gh, or v is equal to under root 2gh. So this is the initial velocity with which the body, this body, strikes the mass m2. So we have got initial velocity, which is u1. Now don't get confused later on, because I just changed the value of v to u1. I was just deriving the formula, and here I have just put in the value of what v stands for here, because u1 is the initial velocity. See, what are four quantities involved right now? u1, u2, v1 and v2. Okay, so u1 is supposed to be the initial velocity of body 1 with which it strikes body 2, and u2 is the initial velocity of body 2 which is right now at rest. So u2 is equal to 0, and u1 is the velocity gained by this body after falling from the height of h. So by that deduction, that if it is at height mgh, the same energy is going to get converted into kinetic energy, and you will get this formula where v square is equal to 2gh, or v is equal to under root 2gh. So this velocity stands for the initial velocity of body m, so u1 is equal to under root 2gh, right? We have got values u1 and u2. Same, applying the same method for v1 and v2. What are v1 and v2? v1 is the velocity with which the mass m1 went back to raise or to get to reach height h1, and v2 is the velocity with which m2 got to the height of s2. So I'll do it separately. For this body v1, it will be under root, by same technique it will be under root 2g h1, and for this body final v2 will be under root 2g h2, right? Putting these four values 1, 2, 3 and 4 in the formula, I'll get E is equal to under root, first of all, v2, which is under root 2g h2, 2g h2 minus root 2g h1, right? v1, this is equal to or upon root 2gh, that was the initial velocity of body m1, minus 0, so I'm not writing minus 0. So this is a way of calculating the value of coefficient of restitution for any two bodies by performing these experiments, measuring the heights and then deriving the formula.